To simplify a complex rational expression, we first need to create single fractions in the numerator and denominator. For some problems those will already exist, but for this one we have a subtraction of two fractions in the numerator and an addition in the denominator. But if we look at the denominators here, we can create common denominators and complete the subtraction, and create a common denominator in the denominator and complete the addition. In the numerator, we can create a common denominator of 5x squared by multiplying the first fraction by 5 in the numerator and denominator, and the second fraction by x. In the denominator, those two rational expressions, I can create a common denominator of 4x by multiplying the second rational expression, the top and bottom, by 4. So the single fractions that we can create and then simplify, we get 35 minus 3x over 5x squared, and in the denominator 7 over 4x. So the next step in our simplification, I can think of dividing by this rational expression. The overall expression is saying divide by 7 over 4x. But dividing is the same as multiplying by its reciprocal. So I can kind of do a little loop-de-loo here and rewrite the expression as 35 minus 3x divided by 5x squared times 4x, I want to take the reciprocal, times 4x divided by 7. Right, so I'm taking the reciprocal of 7 over 4x and multiplying the numerator by that. So now with multiplication, we can create a single fraction simply by multiplying together the factors of the two numerators. So I have 35 minus 3x times 4x and 5x squared times 7. And then if there are any common factors, we can cancel those. And there's just one sort of cancellation that we can do. The x that's up top here, it shares a factor with x squared, so that x, I can take away one of the x's from x squared. So this becomes 4, moving the 4 to the front because we tend to put number factors in the front. 4 minus 3x divided by 35x. 5 times 7 becomes 35. Note that I can't cancel something like the 35, again, because 35 in this expression, this is not a factor of the entire numerator. So I can only cancel things that are factors of the entire numerator. I need to take 35 minus 3x, that whole thing together is a factor. So that's our final answer. That's as simple as we can make it. 4 times 35 minus 3x divided by 35x. So it's always nice to have ways to check problems. With simplifying rational expressions, it's sometimes difficult to do that. One way that we can check our work, though, is we could choose a value or two that would be easy to calculate with, and we could plug those in for the variables. For example, we could choose x equal to 1. I can't use x equal to 0 because 0 in the denominator here wouldn't work. But I could choose x equal to 1 and then plug that in to the original expression and also plug it in to the simplified expression and see that we get the same value. And so with 1, it's not too bad to do the calculation here. I get 7 over 1 squared and 3 over 5. I get 3 over 4 times 1 is just 4, and 1 over 1, so just 1. And then we can try to simplify that result a little bit, as much as we can. 7 adjusting to create a single fraction. Again, we need to kind of think about it that way. So 7 times 5 is 35, so we end up with 35 minus 3 over 5 divided by 3 over 4 plus 4 over 4 would be equal to 1. So we get 3 plus 4 over 4. So that becomes 32 divided by 5 over 7 divided by 4. And again, dividing by 7 over 4 is the same as multiplying by 4 over 7. So from the original expression, we can simplify that into 128. If I plug in x equals 1, I get 128 over 35 from the original expression. So I should get that same amount from the simplified expression. And if I plug in 1, we do. We end up with 4 times 35 minus 3 divided by 35. 35 times 1. But of course 35 minus 3 is 32, so 4 times 32 is 128 over 35. Unfortunately, this is not a perfect way to check because there could be a mistake that I would make that maybe wouldn't be revealed by plugging in just a single number. In order for those expressions to truly be equivalent, they need to be equivalent at every possible value. So we could, if we were worried about it, we could plug in a different value to see if that would make it equal. But certainly plugging in one value, it might catch some mistakes that you might make, sign errors perhaps, and it gives us some assurance that we didn't make a mistake of that kind. All right, I hope you enjoyed the video. Thanks for watching.